All right, what's up, Algebra 1? Today we are working on, today we're working on the 5.4 lesson, which is point slope form, which is to write, our goal today is to write and graph linear equations using point slope form, and then we're also going to use point slope form to get to slope-intercept form, which I think most of us are more comfortable with anyway, and then graph and everything using that. All right, so we'll go ahead and get started. All right, so we're just going to go ahead and look right away at problem 1. Okay, actually, sorry, before we do that, we are going to look at what point slope form actually is. All right, so our point slope form is going to be this equation. All right, so point slope form is going to be y minus y1 equals m times the quantity x minus x1. All right, everything here is still the same as what we're used to. Y1 and x1 are the points or the coordinates of a single point, which we can plug into this equation. We'll get into why we would do that here in a minute. And then m is still slope, so that doesn't change either. So there's not anything that's really too new as far as the terminology and what the letters mean, or the variables, I guess, mean. But we'll go ahead and get into how to use this. All right, so make sure you've got this point slope form written down, and after that you can resume the video. All right, so looking at problem 1, we have write an equation in point slope form. A line passes through the point -3, 6 and has a slope of -5. What is an equation of the line? All right, so this one's pretty simple. We just want our standard point slope form equation here. All right, now we're just going to plug in. All right, so just like with slope-intercept form, y and x will stay the same, so y stays the same, and then we do have our y1. All right, y1 is just our y coordinate for our point, which would be 6. All right, and then m is our slope still, so our slope is -5. X stays the same, and then our x coordinate for our point, which is -3 right there. All right, since it's -3, we're going to add 3, right, because we're subtracting, and subtracting and negative will be addition. Okay, so we have y minus 6 equals -5 times the quantity x plus 3. All right, and that is your equation in point slope form. Okay, so go ahead and give that a try on Got It problem 1. I don't think it'll be too difficult for you, but go ahead and make sure that you've got this under control. All right, so problem 2 is graphing using point slope form. All right, so they give us the equation y minus 1 equals 2/3 times the quantity x minus 2 for our point slope form. All right, so using this, we can find our slope, which is m. All right, and that's going to be 2/3, right, because there's an m value, and we can find our xy coordinates. All right, so that point will be our x1, which would be 2, and since we're subtracting 2, we know that 2 is the point there, and then we're subtracting 1 for our y value here, so 1 is the value there. All right, now we have everything we need in order to graph this. Okay, so bear with me as I draw a nearly flawless graph. I'm sure you're aware of my artistic abilities. So here they come. Try not to be too amazed and awestruck by this. Okay, so here we go. We got our graph. We'll go ahead and go with 4 points on each side of the origin for each axis. And then we have our points x, y. We're going to graph that first. Okay, so we've got the point 2, 1. So there's 2, 1. All right, now we have our slope 2 over 3. Remember that our slope is, and here I'll write this in a different color so it doesn't get confusing. Just remember that our slope m is rise over run. Okay, and we have 2 over 3 right here, so that tells us that we need to go up 2 and then over 1, 2, 3. I needed a 5th point. Okay, we'll put it right there. All right, so there are our 2 points. Now all we got to do is draw a line through them. Wish me luck. Okay, I did it. It was a mostly straight line. Okay, so that's our graph for this equation in point slope form. All right, and then that's kind of what theirs looks like too. All right, so we must have done it right because it looks pretty similar. So that is good news. All right, go ahead and try out Got It problem 2. You'll have to draw your own graph as well, but give that one a try just to make sure that you are able to graph these as well. All right, so once you're done with problem 2, we'll look at problem 3. This is using 2 points to write an equation. All right, so instead of having a point and a slope, you're going to just work from 2 points. Okay, so the points that they give you in this graph are the points, and I'm going to go ahead and label them just because. So I'm going to label them A and B. So point A, we'll call that -2, -3, and then point B will be 1, 4. All right, so the first thing we need to do is try to get our slope. Okay, so our slope formula, in case you don't remember, was m equals y2 minus y1 over x2 minus x1. All right, so we're going to go ahead and plug in our points A and B. I'm going to use A as 0.1 and B as 0.2. So we have m equals y2, which would be 4 right here, and then minus y1, which would be -3. So we're going to add 3. Okay, and then on the bottom, we have x2, which is 1, and we have minus x1, which is -2. So we're going to add a positive 2, and then we're just going to simplify. All right, so we have 4 plus 3 on top, which is 7. On the bottom, 1 plus 2 is 3. All right, so that's our slope, 7 over 3. All right, our next step, now that we've found our slope, is we can go ahead and start writing this into our slope-intercept form. Or sorry, not slope-intercept, point slope form. All right, so we have y minus y1 equals m times x minus x1. Okay, and now we can go ahead and plug in. So again, y stays the same. y1, we can pick either of these points. Because b is all positives, I'm going to go ahead and choose b, just because that's going to make it easier to work with. So our y1 for b, that's our y coordinate for b, is 4. All right, and then we have equals m, which we just found was 7/3. And then that's going to be times the quantity of x, which doesn't change, minus x1, which would be our x coordinate for b, or 1. Okay, and there's our equation in point slope form. All right, so now that we've done that problem together, I want you to go ahead and do problem 3a here, and you should end up getting, well, so you'll do 3a, you'll get something a little bit different, and then I want you after that to go ahead and do 3b. All right, and that'll show you why either one will work. Okay, so give that one a try, see how it goes. All right, so with those last examples, 3a and 3b, you probably noticed that you can write equations from point slope form into slope-intercept form. All right, so that's actually going to be something that is super useful. I personally prefer to work in slope-intercept form most of the time. All right, if you're the same way, you probably found that last bit really useful. So, but we're going to look at problem 4 just to kind of reiterate the idea of writing equations in slope-intercept form from our point-slope equation. Okay, so we've got this word problem. The table shows the altitude of a hot air balloon during its linear descent. What equation in slope-intercept form gives the balloon's altitude at any time? What do the slope and y-intercept represent? All right, so we can just pick any 2 points. We'll pick the same ones that they did. We'll pick this top one, and then we can do this bottom, or this second one as well. All right, so the same way that we did the last problems, where we need to find m to start with. All right, so m is going to be y2, which we're going to say is 590. Minus y1, which will be 640, and that'll be over x2, which is 30, minus x1, which is 10. All right, simplify that. We're going to get negative 50 over 20, which is the same thing as negative 5 halves. All right, there's our slope. Okay, and then we can go ahead and write an equation in point-slope form. So we have y minus y1. We can go ahead and use, let's go with this one. All right, so 640. All right, and then that equals, sorry, that was just in the way. All right, that equals m, which is negative 5 halves, times the quantity x minus x1, which was 10. All right. And there's our equation in point-slope form. All right. Now, it asks us to interpret what the slope and y-intercept represent, which means that we're going to need our y-intercept. You don't have a y-intercept available from this equation, so we're going to have to figure that out. All right. So our next step is going to be to go ahead and simplify this into slope-intercept form. So if you struggled with examples, well, I guess just example 3b, this is going to show you how to do it. All right, so the first thing you want to do is go ahead and distribute. So we're going to have the left side will stay the same, and then the right side, we're going to have negative 5 halves times x, and then it'll be plus, because we have 2 negatives, right? Negative here and a negative here. We're going to do plus 5 halves times 10. All right, that's going to give you 50 over 2, which is the same thing as 25. All right, from here we can add 640 to both sides because we need to get y isolated. All right, so we do that. Now we have y equals negative 5 halves x plus whatever that is. That'd be 665. All right, that should be your equation in slope-intercept form. All right, so now we need to interpret this. All right, so we need to look at it as far as the slope being negative 5 halves x, or sorry, negative 5 halves, and then our y-intercept is going to be 665. All right, and then what that means, this is our rate that the hot air balloon is falling. All right, so this is our rate of change. Okay, and then 665 is our initial balloon height. All right, and that is what it's asking you to find when it says interpret those values. All right, so that is the end of the video. Hopefully you were able to solve these. I'm not going to have you do that last got it problem. We did 3A and 3B, which is pretty similar. The only difference is that it wasn't a word problem. All right, so once you have understood and written down all of this stuff from that final example that we did, you are good to go on this video. And then I will see you guys in class where we will go over it. Okay, so see you guys there.